Okay, so we will start with power. In your grade 10, you have elaborate topic of only two topics in physics, light and electricity. So power will be haunting you a lot in electricity. So try to understand power here. Power, whether you are doing electricity, mechanical device, everything means the same. Okay. So we'll first go for basic idea about what is power, then we'll do some calculations. Now, whenever it turns about power, when we talk about power, a mentality that comes up is, okay, I have got a drill machine, it is powerful, it is a powerful drill machine, our motor is more powerful. So powerful means we feel that our job will be done much more efficiently. Well, that's also correct, because say for example, the walls in Pebble City are all of concrete. Okay, so if you want to drill a hole here, like say I do work on my own, I have got my small drill, big machine drill. So if I use my small drill, it will yell a lot, make a lot of noise, plus it will take time to drill it. The neighbor will also get frustrated. But if you use the bigger machine drill, in one go it will drill it. So we say that has got more power. So one of the way of understanding power are from two sides. Okay, let's understand power. I will go to the definition later on. Let's understand it from the machine's perspective. From the machine's perspective. Okay, machine. And let's take a machine, for example, as a drill machine, a drilling machine. Right. Now I have got two type of drilling machine. One is a low power machine, one is a high power machine. Obviously the high power machine does efficiently, जल्दी कर देता है, ठीक है? लेकिन what is a machine first of all? A machine job easier, but a machine will always eat energy and deliver work. Machines do not produce energy. Obviously, energy cannot be created, not be destroyed. A machine cannot produce energy. मशीन आपके काम को जल्दी जल्दी करने के लिए एनर्जी भी जल्दी जल्दी खाएगा. दो डिफरेंस है. फॉर एग्जाम्पल, लेट्स से आई एम यूजिंग दैट पेडेस्टल फैन फॉर देम. दैट्स अ फैन. यू मस्ट हैव सीन इन शादी ब्याह मंडप, दे हैव दैट बिग फैन. वो ज्यादा हवा देता है, तो वो ज्यादा इलेक्ट्रिसिटी भी कंज्यूम कर रहा है. नो डाउट अबाउट दैट. So let's first understand what is power. Power is defined as the rate of doing work or the rate of consumption of energy. Now, whenever we say the word rate of doing work, we can either say it as rate of doing work, or we can also say it as rate of consumption of energy. पहले समझते हैं चीज को. Consumption of energy. Now, why did I write two different things? See, I'm talking in terms of the perspective of a machine. If the machine is delivering work to me, the drill machine, then I will say it is the rate of doing work. क्या rate में? I suppose we have got two type of people, two helps at home. One help cleans the house, takes 1 hour to clean it. The other help, without any compromise in cleaning, cleans the same house in say half an hour. So we say इसका power ज़्यादा है, ज़्यादा fast काम करता है, ठीक है? So power is the rate of doing work or the rate of consumption of energy. Suppose I have a music system which is 4000 watts and you have a music system which is 8000 watts. The 8000 watts music system any day will be consuming more energy. आपको उतना गाना देने के लिए वो एनर्जी भी उतना ही पिएगा, right? So power is the rate of doing work or the rate of consumption of energy. Why see in the book they may write power is energy by time or rate of doing work. No, understand it from both perspectives. मेरे पास एक ड्रिल मशीन है, इसके पावर को मैं दो एंगल से देखूंगा, रेट ऑफ डूइंग वर्क एंड रेट ऑफ कंजम्पशन ऑफ एनर्जी. ये काम करने के लिए कितना एनर्जी ये खाएगा. अल्टीमेटली मशीन क्या कर रहा है, यही एनर्जी को तो वर्क में is going to eat the electrical energy and deliver mechanical work. Eat the electrical energy and deliver the mechanical work. Have you understood? So a machine eats energy and delivers work, fine. And whenever you see this word called rate in mathematics or anything, you in your mind should think about something which is known as time. Rate माने time. अच्छा, उसका rate कितना है? Rate माने कितना लेता है? Rate. What is rate? Is all related to time. ठीक है? So can we now define power? We will define power as rate of doing work, मतलब work over time. Power can also be defined as energy upon time. Energy upon time. एक ही बात है, कितना काम कर रहा है पर यूनिट टाइम या कितना एनर्जी पी रहा है पर यूनिट टाइम. So let's bring our notations for this. Power is denoted by P, energy by E, time by T, work by W, time by T, power by P. So, and let's see now after incorporating the units. अभी मजा आएगा समझने में, रुको. Work is measured in joule, energy is measured in joule, time is measured in second, time is measured in second. Okay, so joules over second is power and the name for this is watt. आप जो बोलते हो ना मेरा 45 watts का चार्जर है, watt, W stands for watt and watt comes from the name of James Watt. वहां से watt का नाम है, जैसे W कहते हैं. So 1 watt is equal to 1 joule over 1 second. Now are we in a position to define 1 watt? We would say the power of a machine is said to be 1 watt if it delivers a work of 1 joule in 1 second. 1 second में 1 जूल काम कर देता है तो power is 1 watt. Okay, second, another way, the power consumed by a machine is said to be 1 watt if it consumes 1 joule of energy in 1 second. Because देखो हमारा मशीन खुद से एनर्जी नहीं लाएगा. अगर हम इस साइड में मशीन के पावर को देखेंगे तो कैसे डिफाइन करेंगे? E by T. इस साइड में मशीन को देखेंगे तो कैसे डिफाइन करेंगे? W by T. समझ में आया? मशीन इज गोइंग टू, नाउ क्वेश्चन अराइजेस, सपोज वी बॉट अ ड्रिल मशीन फ्रॉम द मार्केट. We bought a drill machine from the market and our drill machine is rated as, suppose we have got 2 drill machines, we have got a machine 1 and we have got a machine 2. ठीक है, अब रियल लाइफ एग्जांपल देखो. मशीन वॉट हमारा है 750 वॉट्स का ड्रिल मशीन और मशीन 2 हमारा है 1500 वॉट का ड्रिल मशीन. ठीक है, हमें बालकनी में एसी लगाना है और होल्स मारने हैं. अभी ऑब्वियसली चॉइस विल बी फॉर दिस. ये फटाक से कर देगा, बड़ा होगा, मारेगा, एक बार में चला जाएगा. हाँ, अभी बात आती है, ये दिस इज कॉल्ड द मेकर्स सिग्नेचर. मतलब व्हेन यू बाय द मशीन दिस विल बी व्हाट रिटन ऑन द पैक. व्हेन यू बाय ऑन Amazon इट विल बी रिटन 750. ये कौन सा वॉट बोला, पावर बोला, ये वाला कि ये वाला? ये भी एक बात आता है, ये वाला कि ये वाला? ये जो भी लिखा रहता है ना, ये लोग एक्चुअली ये वाला बोलते हैं, इतना पिएगा. अब सवाल आता है, हमें कितना यूजफुल वर्क मिलेगा? नहीं, हमने ये मशीन खरीदा. We have bought this machine from Amazon. Okay, this machine is printed. इस ड्रिल मशीन में प्रिंट है 750 watts. That means this machine is going to consume, अगर मैं इसको 1 सेकंड चलाया, is going to eat up 750 joules of electrical energy. My question is, how much work will it deliver? That is the answer I was looking. It won't be 100%. क्यों? ड्रिल मशीन चलाने से नॉइज नहीं होता है क्या? होता है ना. Is that useful work for me? No. ड्रिल मशीन गर्म नहीं हो जाता है क्या? हाँ, होता है ही. स्पार्क्स भी आता है कभी कभी. ठीक है, तो हम लोग जो the power at input, always remember our machines are such designed that suppose this is power at output. In real world, the power of output will always be less than the power of input. Always less. और इसका जो difference है, that difference is known as loss of power. This difference is known as loss of power. So sometimes we may say, look, I bought a drill machine of 1500 watt. Do you think it will deliver work at 1500 watt? No. It will have some 5% losses. Then we use a term in higher engineering called coefficient of performance. 95%. So the coefficient of performance of my drill machine is 95%. मतलब ये अगर 100 रोटी खाएगा, 95 रोटी का काम करेगा, 5 रोटी खुद भी तो लेगा. Now if you cook biryani and take it to someone's house, by the time you are going from this house to that house in scorching sun, थोड़ा हटा के 2 चम्मच पिचिक पिचिक खुद भी खाओगे और फिर ले जाओगे. That's the idea. The process loss will always happen. Nothing can give you exact. You don't have any machine in this world which converts 100% input to 100% output. In that case, the machine's efficiency is 100%. So let's go back now. What is power? Power is the rate of doing work or the rate of consumption of energy. Sir, why do you define it in two ways? Obviously, if you want to look it at the perspective of energy consumption, that is, you want to look it from the input side, then I'll say how much of energy it is eating. If I want to see it from the perspective of delivery, how much of work it is doing, I'll see the power output. For an ideal machine, this should be equal to this, but nothing is ideal in this world. This will always be less. Always be less. Whatever we feed into something, the output you're not going to get same. Any device, if you even take a toaster, उसमें भी losses रहेगा. Every device will have losses. They will get heat up. They'll have heat. Heat is the first thing in which losses happen. Even if you have any machines which are running, heat loss will be there. Friction will be there. Have you understood this idea first? Okay. Now, when we talk about watt, we bring some bigger units also, and a bigger unit is known as a kilowatt. K in small, W in capital. 1 kilowatt is equal to 1000 watts, which is equal to 1000 joules over 1 second. This is a bigger unit. For example, when we buy iron, electric iron, or the geysers that we buy, we'll say our geyser is 3 kilowatt. Our geyser is a 3 kilowatt geyser. 3 kilowatt geyser मतलब 3000 watts. काफी अच्छा गर्म होता है. That means ये 1 सेकंड चलने से, ये 1 सेकंड चलता है तो 3000 जूल पी भी रहा है. Now let's talk about air conditioners. Air conditioners will be around 5000 के आसपास आ जाता है. बहुत ज़्यादा watts कंज्यूम करता है. ठीक है? Like we have, for example, let's say in our days, you see how people have started to become efficient. Now, this was our school days. We used to have bulbs which used to be 100 watt. Have you seen the glass bulbs of 100 watt? अभी भी villages में, रत्नदीप में अभी भी मिलता है शीशे का बल्ब. ये जलता है, इसको जलते जलते आप जाके पकड़ सकते हैं. नो, इट्स वेरी हॉट, वेरी हॉट. सो हीट में लॉस हो रहा है. ऑल वी वर इंटरेस्टेड टू गेट वाज लाइट एनर्जी. क्या आपको लगता है 100 watt का लाइट एनर्जी आ रहा है? नो, it is heating up. And not this tube light, this is 40 watts. The general tube light in your house is only 20 watt. Don't you think 20 watt में हम टीवी देख सकते हैं, आराम से पढ़ाई लिखाई कर सकते हैं? And these lights, these ones, ये जो छोटे वाले हैं ना, these are 3 watts. Just see the power, just see how much efficient LED makes it. But again, when you switch on to an LED system, the LED system's cost is more. Initial cost is more, but over the period when you run it, it balances. Like these lights, each of these tube light is 40 watts. So right now I am burning how much? 4, 160 watts are being burned. However, this one is a 20 watt. This is a 20 watt tube. But this tube is sufficient for me in normal case. This is a 20 watt, that's a 20 watt. And the bulb we used to run used to be 100 watts. कितना ज़्यादा बिजली जलता था, just सोचो. Able to get it now? So therefore we have nowadays, we have always low efficiency. Your job should be that you should consume less and less amount of energy as possible. So what is power? Power is the rate of doing work or the rate of consumption of energy. Now let's say some examples, okay? And one more unit you should know. ये इतना समझ में आया? Okay, थोड़ा सा मिटाता हूँ, कुछ और बताता हूँ, आ जाओ. So we will do some problems from higher books also, not only from our Lakshmi Singh only. So if we have a machine, the machine is going to have always an input power, and this is what is stamped on the machine, and it is also going to have an output power. Okay, output power. And in normal cases, this will always be more, and whatever is the difference, delta means difference. Okay, whatever is the difference means input minus output, because input is more, that is known as loss of power. और ऐसे machines बनाइए जहां loss of power कम हो. Loss of power means you are just losing energy. You are paying for the energy, but you are not being able to use it. ये खराब हो रहा है आपका.
What is the maximum output a machine can have?
That depends on types of machine. Suppose if you have we get the highest amount of outputs, you will see in sort of LEDs and all, the efficiency is very high. But however, wherever it comes to like mechanical devices जब आते हैं ना, like drill machines and all, any heating device will have less efficiency. Mechanical devices like your drill machines and all will have around 90%, 95%, 90% तक efficiency रहता है उनमें. Yeah.
So even what is it? That
हाँ, I didn't get
will
you.
also have.
फिर से बोलो बेटा.
Well, even these phones will also they'll also consume less battery and less energy, and they'll give up and they'll also be efficient in
Which one? Which one? I'm not able to hear you. Hear you means speak slowly. Which is will give you more battery life?
Like these days, what is it? Phones take less energy consumption and have efficient battery life also, right?
No, that is not efficient battery life. The battery capacity of the phone is more. Like you can have a 1200 mAh battery. Somebody has a battery which is 56 mAh. If the battery's capacity is more, it will give you more hours of backup. That is what you are getting. Like earlier we used to say in an iPhone, the battery's capacity used to be less. That's why you will need recharging very frequently. Again, you have got some chargers which have got higher capacity to charge, like a 45-watt charger. It's called a brick charger. So it can deliver more energy at a time. 45 watts matlab it can deliver 45 joules in 1 second. ठीक है, वो 45 joules तक आपको दे देगा 1 second में. So energy efficient का मतलब है a process in which amount of energy you have given and the amount of work you are able to get out from it, that should be maximum as possible. जितना लागत लगाया उससे ज़्यादा आना चाहिए. क्या ये चीज़ समझ में आया? In grade 10, you will be learning more about electrical energy and power, but the same concept remains with you. The concept does not change. The concept remains as power is equal to energy upon time. What is the power? And for God's sake, yaar, get bottles or tell me if you want one bottle each. It doesn't cost me. I'll get one bottle each. Class जब चलते रहता है ना, ये उठ के जाया मत किया करो. Just because I don't say anything. I mean, that's not my cup of tea to teach. I cannot teach that way. कर लो. बस बहुत अच्छा, मार्क्स मिल गया. ठीक है. Power is equal to energy upon time, which is equal to 20 joules divided by 5 seconds, which is equal to 4 watts. Excellent. चलो नेक्स्ट क्वेश्चन. यही लेवल के हो, यही सब प्रॉब्लम करो. ठीक है. We have a pump and the pump takes 10 seconds to lift 100 kg water, 100 kg water to a height, and the height is 20 meters. Calculate the power of the pump. If you have understood, you should be able to understand. You should be able to work this problem. कितना आया? क्या किया?
Work is equal to mass into displacement. So we get joules.
Work is mass into displacement. Which great scientist told you that? I really admire your audacity. एक तो गाल में हाथ लेके बैठे हो, एक तो लिखते नहीं हो, and then you think that verbally करने से प्रॉब्लम हो जाता है. कैसे आया? Work is equal to. ये प्रॉब्लम कुछ समझ में आया? All of you must be having your ancestral homes, फादर का घर, मम्मी का घर ऐसा रहता है ना. सुनते नहीं हो वहाँ जाके, ए मोटर ऑन कर देना, टैंकी में पानी कम हो गया है. एक तो तुम लोग यार मजेदार है, अपार्टमेंट में रहते हो. इफ यू स्टे इन इंडिविजुअल हाउसेस, एवरी इंडिविजुअल हाउस यू विल हियर दैट, ग्रैंडपाज हाउस और अंकल्स हाउस, ए मोटर ऑन कर दो, पानी कम हो गया है, पानी कम हो गया है, मोटर ऑन करो. व्हाट डू यू मीन बाय दैट? कभी आपके अंदर ये शौक नहीं जागता है दैट माय डैडी हैज गॉट अ 3-storied हाउस? What type of motor should I buy? What should be the capacity of the motor so that we are able to pull water from the sump or from the borewell to our tank top? ऐसे सोच नहीं आते हैं. अगर वो पुल ही नहीं कर रहा है फिर ये क्या? ये ऐसा नहीं होता ये प्रॉब्लम. What is the value? कम नेहा बोलो. Any trial? Would you like to try? Yeah, go ahead.
So I use cos theta.
So first of all, let us understand this problem. See, in physics, everything is about diagram. Okay, let's see the diagram. Okay, so we have a pump out here. Let's say this is our pump. This is actually the symbol of a pump. So what is our pump doing? Our pump is lifting 100 kg of water to a height of 20 meter. That means the pump is lifting water to a height of how much? 20 meter. And how much of water is it lifting? 100 kg water it is lifting to a height of 20 meter. Don't you think that when the water will be lifted here, the water will gain potential energy? That is the energy. What is potential energy का फॉर्मूला आपको पता ही था. Potential energy is what? mgh. You learnt in last class. mgh करने से m का वैल्यू दिया हुआ है, g you know 10, h you know. Another way to see is that if you don't know this formula, then how much of force is acting? 100 into g. You are lifting it with a force of 100 into g on this side through a distance of 20 meter. Work is equal to force into displacement, not mass into displacement. A great man said mass. So it's force into displacement. So force into displacement is going up. So our power any day will be power is equal to energy upon time. So what is the energy in this case? The electrical energy is being spent. Why? To store the water in the tank so that somebody get the ground floor, when they open their tap, they get water. So the water should have energy. You converted electrical energy, did some mechanical work and stored it as potential energy. So what is the potential energy? Tell me. The potential energy is mgh and time is time. Now calculate this. आपका आंसर आ जाएगा. 100 is your mass, g is 10, height is 20, divided by time. Time should be in seconds, so 10 seconds. Yeah, 10. So let's cancel this and this. It becomes 20 into 100 is 2000. 2000 watts, which is equal to 2 kilowatt. They don't give you, but just keep in mention, in old days power was measured in a unit called horsepower, because those days machines were not there, so people used to compare everything as horsepower. Even in today's day also, if you go to a plumber shop and you ask for a motor, they will ask you साहब कितना HP का चाहिए. HP means how many horsepower. So horsepower's conversion is 1 horsepower is equal to 746 watts.
Is it the same horsepower we see in
Same horsepower. When you say BHP is brake horsepower. 1 horsepower is 746. मतलब कैसा है? पुराने ज़माने में people used to think horse can pull a body of 75 kg through a distance of 1 meter in 1 second. So from there horsepower concept comes. So the engine of Rajdhani and all, they are like 4000 horsepowers. The Rajdhani Express की जो engine, it's like 4000 horses are tied in front of Rajdhani. That's the comparison. So with that forces they pull. So horsepower. ठीक है? करें एक और problem. Power छोटा topic है, right? Let's take one more problem. Is this understood? चलो एक और करते हैं. We have an electric bulb and it consumes 7.2 kilojoules. Okay, so you have an electric bulb, and the electric bulb consumes 7.2 kilojoules. इतना energy consume करता है. 7.2 kilojoules in 2 minutes. एकदम CBSE question. Calculate the power. हाँ याद है. How much? 7.2 kilojoules in 2 minutes. कर पा रहे हो कि नहीं? ये समझ में आया? तो आसान है. पावर का डेफिनेशन क्या है? पावर इज इक्वल टू एनर्जी अपॉन टाइम. 60 watts. वेरी गुड. 7.2 into 1000 because it's kilojoules. So many joules divided by 2 minutes. 2 into 60. ठीक है ना? So 0 ने 0 को काट दिया. 12 6 is 72. तो इसको करेंगे तो कितना आएगा? 1.2, right? And then this is divided by this. This is 0.6. 0.6 multiplied by 100 is 60 watt. मजेदार. Actually, this concludes our chapter also. These portions are all taken up. We can do some more. देखिए ऐसा एक क्वेश्चन करते हैं. आओ. We have a boy. This boy carries. The boy carries 40 kg. Okay, the boy himself is 40 kg. The boy himself is 40 kg, and he carries a box of 20 kg. Okay, carries a box of weight 20 kg to a building top, and the height of the building is 15 meters, and he does this in a time of how much? 25 seconds. He does this in a time of 25 seconds. They asked you calculate the power. ठीक है, a boy of weight 40 kg. So end of the day, our problem boils down to something like this. We have a building. The height of the building is how much? 15 meters. And we have a boy out here. And the boy is also carrying a box in hand. 20 kg. तो यहाँ से आप समझ लो, आइडिया लगाओ. So when it goes above 15 meters on the building, it's not that the box has gone to 15 meters. The boy has also reached 15 meters up. It's in physics, it's one body. And one body means the mass is how much? 35 kg. Sorry, 60 kg. So ultimately, they both reach in this position with the box in hand. So this was 60 kg and 60 kg goes up. So what is the energy here? M into G into H, 15 meters, 16, and this divided by your time, that is 25. So our power will be equal to mass 60 into G into H of 15 divided by time of 25. So 5 3s are 15, 5 5s are 25, 5 12s are 60, 12 3s are 36 into 10, 360 watts. ठीक है? ओके, एक और करते हैं. We have a car of weight 200 newtons. This you do. We have a car and the weight of the car is equal to 2000 newtons. 2000 newtons, and it climbs a hill. It climbs a hill with a steady speed. Every word is a keyword. It climbs the hill with a steady speed, and this steady speed is 8 meters per second, right? And in doing so, in this process, the car gains a height, and that height is equal to 120 meter in 10 seconds. Question is, calculate number 1, work done, and calculate number 2, power. Calculate work done and work done by car and power of engine of car. Okay. Try to draw a nice illustrative figure and try to think how this problem should be attacked. We have a car, the car weighs blah blah, it gains a steady speed to climb an uphill, and it goes with a speed of so and then it attains a height of so and so.
Burger is 2,400 joules.
Starts climbing a hill and it gains a height, means ultimately the car has reached at this place. Okay, and it has reached a height of, this is what is the height is 120 meter and the time taken is 10 seconds. Now you yourself think. Yeah. Done?
Burger has 2,400 joules. No.
Work done is how much? What is the formula of work done? Force into displacement. Displacement. चलो कोशिश करो ना, छोड़ क्यों देते हो? वर्क डन निकालते हैं. वर्क डन
Burger is 2,40,000 joules.
is equal to force into displacement. कैसे निकाला इस प्रॉब्लम को? नहीं, 24/4 से मतलब नहीं है, प्रॉब्लम को कर देना, वो तो आंसर कुछ भी आ जाएगा. What force did you take and what displacement did you take?
What's the rate of
Displacement is velocity into time, right? So if I take velocity into time, then what I'm, and there is no acceleration, steady speed. Steady speed means you are actually getting this much distance you are getting. How much is this much distance? If you do velocity into time, 8 multiplied by time is 10. So this should be 80 meters. So what are you think that work done is how much? Force into displacement. Force is 2000 into displacement into 80. मतलब पर आप ये नहीं लगा रहे हैं, सोच नहीं लगा रहे हैं. This is your car. Where is the force acting? Downwards. Do you agree, Neha? Where is the displacement going? In this direction. The displacement is in this direction. The force vector is in this direction. What did we learn? Work is always done direction of the force. You are not moving in the direction of force. ये डिस्प्लेसमेंट क्वालिफाई नहीं होगा इसके लिए. कैसे क्वालिफाई होगा? फोर्स और ये एक जैसा नहीं है ना. सपोज द इंजन हैज एक्चुअली डन जॉब. ऐसा नहीं कि इंजन ने काम नहीं किया है, पर व्हेन वी विल गिव मार्क्स टू द इंजन एज टू हाउ मच वर्क यू डिड, डोंट यू थिंक द इंजन एक्चुअली लिफ्टेड ओवरऑल. आई टोल्ड यू ना, वो स्टेयरकेस वाला प्रॉब्लम दिया था. 2000 न्यूटन को इंजन अल्टीमेटली ये डिस्टेंस मूव करवाया है. 2000 Newton force is acting on this side. So the engine must give a force which is equal to 2000 Newton, and it has to pull this in the displacement direction of how much? 120 meter. Now is force and displacement in same direction? Yes. This is the work done, not this. यहाँ होने से force और displacement एक ही direction में नहीं है. वर्क जब भी आप कैलकुलेट करेंगे ये दोनों एक ही डायरेक्शन में होना पड़ेगा. या तो होना पड़ेगा, then you can now ask, sir, what is the work done by the engine in going in this direction? There is a work done. In that case, they have to specify me the theta for this angle. मुझे ये थीटा देना पड़ेगा, तब मैं इस डिस्प्लेसमेंट को दो कंपोनेंट में तोड़ूंगा और फिर करूंगा. वो तो नहीं दिया ना. So this is the ultimate work done. Machine was here, mass was here, mass got lifted here. Again, potential energy question. M into G into H. Do you know M? Yes. Do you know M? Yes. How? You know M. Divide this by 10. W is equal to mg. And you did not find out M separately. What is potential energy? mgh, which is equal to W into H. W already given to you. Multiply this by H. आपका इतना एनर्जी आ गया. और पावर कैसे निकालेंगे? This energy divided by 10 seconds. ठीक है? कितना आंसर आया आपको? हाँ, 24 kilowatts and 2400 kilojoules. ठीक है? नेहा अंडरस्टूड. ये वाला कभी नहीं लेने का. सी ऑलवेज ट्राई टू सी फोर्स किस डायरेक्शन में है, डिस्प्लेसमेंट किस डायरेक्शन में है. नाउ अल्टीमेटली इंजन ने यहां तक यहां पुश किया, पर हम जब ऐसे ही देखेंगे, हम देखेंगे इंजन कुछ नहीं किया, यहां से यहां तक एक चीज को ऊपर उठाया. ठीक है? ओके, तो ओके, दिस वन हॉट्स प्रॉब्लम करके देखते हैं. ये सब भी आप लोग के लिए हॉट्स ही हो गया है. एक और प्रॉब्लम करते हैं. Have you been able to understand, Sanvi? Sorry, did you understand this problem or not?
Yes.
Okay, one more problem. Chalo. In loading a truck, a man lifts boxes of 100 Newton each. So the problem is all about truck loading. Truck loading. When the truck loading is happening, there is a man, and the man lifts boxes of 100 Newton each. The man lifts boxes of 100 Newton each, and he lifts them through a height of 1.5 meter, and the height is 1.5 meters. This is the height through which he is lifting each of these boxes. Okay, first question is, how much work is he doing in lifting each box? पहला क्वेश्चन आंसर कीजिए. हाउ मच इज द वर्क डन इन लिफ्टिंग ईच बॉक्स? The question is simple, Betu. There is a truck loading happening. Okay, a truck is getting loaded. There is a person, a loader, and the loader lifts boxes which are 100 Newton each, 100 Newton crates, and he is lifting them through a height of 1.5 meter. So they have asked you the question: what is the work done in lifting one box?
The work done will be 150 joules.
Work done will be, so if you see what is the height through which it is lifted, the height is 1.5 meter. What is the box? The box is 100 Newton. 100 Newton means this is equal to the mg product. Height itna hai, so work done is equal to the potential energy that will get stored. So mg ka value aapko already 100 de diya hai, multiplied by 1.5. So this becomes 1.5 means 1 more 0, 1500, sorry, 150 joules is the work done. Clear? What happened, Aparna? जोश नहीं है, नहीं लिख रहे हो? Where you were sitting aram se with backrest likhe. Okay, the next one is how much energy is transferred when one box is lifted. This is work done. The next question is how much energy is transferred? How much energy is transferred when one box is lifted? This is a common sense question. When one box is lifted, how much energy is transferred? Need not do this problem. Whatever work you are doing is getting transferred as energy. So how much energy is transferred? 1500 joule. You are doing work with 1500 joule. Where is the work gone? That is transferred to the box. अब वो बॉक्स ऊपर से गिरेगा तो 1500 जूल का वर्क कर सकता है. Last question. If a man lifts 4 boxes per minute, the last one is little bit interesting. One man, he is lifting 4 boxes per minute. 1 मिनट में 4 बॉक्स उठाता है. Okay. What power is he working with? Calculate his power.
2.5 watts.
Okay. 4 boxes he is lifting. So for every box, how much of energy is going? 1500.
150.
Sorry, 150. So 4 boxes means
150 by 60.
150 into 4. 4 boxes.
Yeah.
So 150 into 4. 150 is the energy for one box. Okay? So 4 boxes per minute. So let's find it in this way. Power is equal to energy upon time. What is the energy? Mass. What is the mass in this case? We are having 100. So we have 400 is our mass into m into g becomes 400. Height is how much? 1.5 meters. This is energy divided by time, and the time is 60 minutes. ठीक है ना? 0 ने 0 को काट लिया, and rest you can do. 15 into 4 is 60, and 1 15 460 and 100, so 160 divided by 6, which is equal to 10 watt. Did you understand this? He's lifting 4 boxes. Enough. Maybe I'll circulate one worksheet from this chapter. Try to do that worksheet because that will help you in your break and all. I know it becomes dull. Yes, I also lost my, what do you call, pleasure and energy to teach. But that's the way it is. So the idea is that I prepare my whole day for a class when it comes. It's just that मैं just घर से आ जाता हूँ, ऐसे class करने नहीं आता हूँ. Next time when you all do these things, I have little bit of what to say. बार बार बोलने से पूछोगे ये आदमी खाली चिल्लाता है. You can do one more. A man weighing 500 Newton carries a load. This is all you have done. Right, fine. I think there's nothing more left. We can call it a day. If anyone has any doubt out here in this section, I can explain again. Any doubt related to power, any doubt related to energy, any doubt related to work done. So this chapter hovers over 3 concepts. The first one was work. Work is said to be done when the point of application of force moves along the direction of force. Work is always F into S into cosine of the theta. If they move in the same direction, theta is equal to 0. If they move in 90 degree, theta is equal to 90 degree, theta is equal to 90, cos 90 becomes 0. And if they move opposite, theta is 180 degree, cos of 180 is negative 1. After that, we learned about energy is the ability to do work. Work and energy means the same.